Alright, welcome to the video. This is going to be a introductory video of the some of the goals and why I'm doing this project, which is a project to basically make, I should say, a tile, an Ultima-style tile engine. And we're going to mimic Ultima here because it's just easier. We've got the tiles, we've got the format, and use that as a base. And what I had in mind with this was, for years I've been thinking about this because I've been working on a similar project on an Atari system. And I thought the Atari and other systems are much, much easier to deal with the graphic screen memory, because on the Apple II it's all weirdly laid out, and there's other things. And I thought, when I've seen the actual Ultima games, I always thought that the animations could be smoother and faster. And I'm like, well, is it just they didn't know and we just know better now how to deal with that stuff? Or, was there just a lot of overhead they had in the game, or whatever considerations there might be? But it gave me some ideas about thinking about how one might go about doing the screen draws, basically. This is all about performance for the most part, to see just how fast and smooth we can get things running on an Apple II, and see if we can improve it, Now, there are going to be some design considerations for that, which we'll talk about as we go forward. But the goal here primarily was to get the tiles, there's a whole video coming next about just getting the tiles made up into sets that are laid out like you'd want to have them laid out. So there's a whole video on that to get those set up right, so that you can load them into memory, and then they're set up, because every tile is 2 bytes wide, 16 bytes tall, 32 bytes, and they're just sequentially laid out in memory. So every 32 bytes is a tile, and getting all of that in the right places and set up correctly, because I couldn't find really anybody that had that. So I got a whole video on how I made those sets to produce the screen you see here. This particular screen you're seeing is just a dummy map. This is not an actual map from one of the Ultimas. I just made if you can see here, we've got some of the code here I'm working with. This is the program, and I've got I built in a couple of buffers for maps. This is not the map data that you would have of like what gets pulled in from the disk. This is just a map buffer that you construct. This 11 by 11 grid. The tiles are 11 by 11. The map, I should say, on screen is 11 tiles wide, 11 tiles tall. You sit in the center. And so I just built in some buffers, stuck some padding so they would fit on a page boundary. Or, well, not really a page boundary. Technically, it's 128 bytes, so it's actually half. But all of this fits in one page, one 256 byte page. But I needed that so everything else, like the tile set, tile address table, and other things would come out. This table, we'll go into the code more later, but and then I have a table here, for instance, that will let me quickly derive the starting address of the tiles for any given index. So if you have tile 5, you go into the table and you pull the fifth one and construct your address from there. Got a split between high and low, so you can single byte index into it. We'll get into more of that later, and the particulars of that. I don't want to get in the code right now. Right now is just more the design philosophy and what we're trying to do. So the idea here is that we want to get to a point where we have a basic, or not a basic, but we have a screen draw routine that draws the screen as quickly as possible. And again, I didn't know where this was going to end up in terms of performance. And we'll see in a couple of videos where that comes out when I get to the point of getting the animations for, like, the water, for instance, done. But the actual screen redraw itself, as best I can determine, well, I don't know how it is in milliseconds, but it's very fast. Now, I came up with a method that's very quick, but it is extravagantly memory expensive, because unlike the normal way you would do this, so this actually does paint one tile at a time. Just to back up a step, there's been some interviews over the years, but not a lot of detail about how they did their screen draw routine. One of the main programmers says he would draw the top byte of the entire row across all of the tiles, and then do the next one and the next one and the next one. So he would draw the screen line by line across all 11 tiles for each row all the way down. And I could not figure out how that was saved. There's one area that saves you time, but it doesn't really save you time particularly in getting the tile data, which you really can't get around. So I really couldn't figure out how they did it. There was no elaboration on that. And there were some other things, maybe with Ultima 5, they may have done where when you move, when this map moves, it says, oh, is this tile the same as what was before? That's why I have 2 map buffers here. We're going to implement that eventually. So we will basically say, when you move, it'll copy map 1 to map 2. It'll then construct map 1 from the main map. And then it will start comparing bytes as it goes. It'll pull this, it'll start here and process the screen. But it'll pull from this map buffer down here and say, hey, are these 2 bytes the same? These 2 map tiles the same? If they are, it skips it, and that'll save a lot of time. Similarly, there was also some mention about only redrawing tiles on the screen that have animations. I got to figure that out because you have to be able to say you only have to animate the tile once per screen. I got to figure out a quick way to do that. There's ways to do it, but I'm trying to figure out a quick way. The quickest way is to make another table, a 256 byte table, that you clear in between each frame, and you just, the first time you encounter, let's say this is tile 1, you put a byte in there and flag it basically, or some other variation of that. And then when you run into it again, you check that table and say, have we already animated this tile? We've already run the animation? Yes. And so you skip the animation update because you're trying to do the whole frame here, and then you just continue on until you get done, and then you repeat everything. I'm still working on that part of it, which way I want to do that in terms of memory versus speed. That'll certainly work for speed, but anyway, so things like that. This was some of the discussion in the past from some of the developers and in various interviews. I'm going to use a hybrid of some of those methods. I'm definitely going to use the comparison for tiles between screen updates. I want to have it set up so that we have, I think I've even got a note here. I want to set up a screen redraw flag, basically, where we use to determine what you want to do at any given time. So if you're just idle, it will only update the animations on screen because you're not moving. So it'll only check for animated elements, and it will animate them and then only draw the tiles that are animated. That would be much, much quicker, obviously. One would be movement-based, where I just mentioned where you compare the 2 screens and you only update the elements that changed from one movement to the other. And then the other was where you force a full redraw, which would be something I thought about that, and I thought, well, I want to have it. I suppose a practical application would be something along the lines of you teleport from one location to another in the map. You go to a different place entirely, and I will mimic that when I get my thing built here. I'll have a dummy section of the map loaded in by Lord British's castle. I'll have 1 kilobyte, so basically 4 sections of the map loaded into memory, which actually I'm going to manually construct down here. So I'll have a whole map table down here, which could then act as the buffer. But anyway, we'll get to that. And then we will move around within that map using this little engine just to make a quick and dirty kind of movement system to test all of the various screen update things. And remember, the question here is how fast can it be done? And we're not really saying memory be damned, because there's a way to do that where you could use about 30K of memory for the routines. But we are trying to say, where's the most efficient way we can do this and get it to update the screen as quickly as possible. My best guess right now is to animate this full screen redraw. So if we redraw this entire screen, we update the animations of these 3 tiles. There's 3 water tiles here. So this is my best estimate. We update these 3 tiles, which we move the water down 1 byte, basically, to animate them. So this is all scrolling down. There are 3 different types of water here, so we animate those 3 water tiles in memory. We move the tiles around in memory, the bytes, and then we do a full redraw of the entire screen, and we repeat that. My best estimate, given the routines I've got here and the calculations I've done, is I should be able to get somewhere between 6 to 8, maybe 10 frames a second, which is a lot faster than the Ultima games, which again, they could have a lot of overhead for other stuff they have to do. I don't think when you're just paused, though, because it's a turn-based game. So if you're just sitting here and you haven't pressed the key or anything like that, and it's just animating the screen, then that's all it should need to do, which should be fairly fast, but it still comes out to be something like 5 or 6 frames a second, maybe 4, maybe 5. I'll try to record in the emulator and pull that footage into a video editor so I can literally break it up into a 1-second chunk and try to get an idea of how many frames are updated. I should be able to do that to get a rough estimate. which might be off by 1 frame or so of the animations. So I'll do that with the Ultima series, and I'll do that with my thing, and I'll report the results in a later video when I get to that point. And so we'll do comparisons and see what that is. But my best estimate is I think I can double the frame rate that you see in Ultima. Now, like I said, and just to give you an example here, this is extravagantly expensive compared to the normal way you do it, getting back to the idea. The normal way you do it, and actually before I do that, just real quick, instead of drawing that whole line across, all the way across like the other guy did, this is done a traditional way. We draw this tile, we draw this tile, and we go across the row. Then we reset, we draw this tile, we draw this tile, and so on and so forth down. Just like you do a raster scan, right? So, so we do it that way. But the normal way you would do that is you'd run basically 2 loops. You run, or not loops, but indirect addressing of some kind. You'd run one to get the tile data, which is usually using 0 page, comma y method, which we do because we have this table of the tile addresses. So we derive our tile address within just like 10 cycles. We just grab the tile address, the starting address of the tile, and we stick that into 0 page, and then from there we can just go 0 through 32 or 31, or 0 through 31, I guess, 32 bytes. So we do use that method, even though there's a little bit of a penalty in terms of cycles, because it's a little bit slower. It's 1 cycle slower per byte per get. Putting it on the screen is the same, but getting it is 1 cycle slower per byte. So there are a number of cycles in here that you're kind of losing out on that way, but it's the only practical way to really do it. Because you can derive the address, but you'd have to stuff that address somewhere as a starting point, and you still need to be able to kind of move across that, data. But the advantage to that, and this is getting a little more into the code aspect, we'll talk about this more later, by doing it that way, and because they are based on 32 bytes each, everything comes out even with respect to page boundaries. 32 times 8 is 256, I think. Yeah, 32 times 8 is 256. So you're never crossing a page boundary with that 0 page load. Or if you do, you might get one off the end if you don't do your count quite right. I think I'm counting down to 0, but anyway. Or I'm counting up. So theoretically you might get 1 grab, but it would only be 1 per tile if you went off the edge before it did the check to see where you're at. There's maybe 1 or 2 more efficiencies we can do in the looping on that. But the actual way it deals with the screen, okay, the normal way you would do this for the screen is you would create a table, which I do have but I'm not using right now, and you'll see why in a minute. You create a table that has the addresses for all of the rows in sequence. So this is the low byte for row 0, 1, 2, 3, 4, etc., etc. The high byte for 0, 1, 2, 3, 4, etc. And you would index into this table. You would then get the row that is on, and you would then go across and do your thing from there. Once you've got the starting row, you can, because it's only 40 bytes wide, you can index across with the register, with the X or Y method. So you've got a couple of options there to do that with. And certainly you have options within doing the looping structure. But to save time, that looping structure and using the indirect addressing is a tad, it's not slow, but it's not the fastest you can do it. And getting to the screen, you would incur a cost of constructing the address. You have to get the address. Then you have to do the indirect looping, the checking the loop. Every byte you do in a loop, you got to check to see if you've reached the end of your loop. Or there's ways around that, but there's still a couple of cycles in that. Even if you do like the countdown tricks where you go 0 to 1 and everything, or down to 0 and branch only when it goes past 0 and all that stuff. There's still a check involved in that, which is minimal, but you still have a check like that. However, the fastest way, and certainly not in any way the most memory efficient, is to do it direct. And the way we do that here is, get ready to hold your whatever. So we have a construct here that tells us which tile on the row we're drawing, and we have a specific routine for the tile row. So this is row 0. This is the first 11 tiles. And we have a byte here to tell us which tile we're drawing across that row, 0 through 10 as well. And then we hard code, and we literally unroll the loop, what would be a loop, and we go across the row by hand, essentially. So we hard code all of the screen addresses that we're doing. We use the indirect X, and the reason we do this is because A, it's easier, and B, it is a little, because you still need the variability of which tile you're going to be on. So we do incur a slight cost here by getting the tile X and multiplying times 2 to get the offset across the row. You'll see this too. We also have to add one because there's actually technically a border that would exist, and these tiles don't line up if you put them at the absolute left of the screen. They come out, the colors come out wrong. Anyway, we'll get into that. But you do use the X-index method, and you hard code the addresses per line. So because there's a border on the screen, we start at line 8. 0 through 7 is the border of the window. So we start at line 8, line 9, and I explicitly put these in so it was easy for me to follow, because I have to pull everything from the addresses in a spreadsheet like this. So I had to lay everything out in terms of, this is the border, this is the tile row, this is the address, the next tile row is here, and so on and so forth, with the actual screen row on screen. And I was just doing this very explicitly and copying this. So again, this is extravagantly expensive in terms of memory. It's probably not practical from a game engine standpoint unless you're doing a fairly simple game. And it would probably help if you're running on a 64K machine where you can stuff some of this data and some of the tiles and buffers and some other things under the ROM. Now, this is not absurdly expensive, but compared to what you could normally do, this whole looping stuff would normally be a few hundred bytes or something. This, because we're doing, mind you, we're going down the row here, and we're manually putting these in. Oh, and the other thing is, this method, by the way, this comma X in absolutes, is no different in terms of cycles than just storing it without the X. It's the same cycle, number of cycles to do. And it is one less than this method, which is the indirect method. So you are saving one cycle per store on every byte on the screen. And there's quite a few of them, because if we calculate that out, we have, think about that you have to think about these kind of terms. We have 121 tiles, right? And there's 32 bytes per tile. That's 3.8K. That's 3872 bytes that are being read and written to the screen. Mostly the point is the writing. If we did this method and use the indirect method, you now have 3,872 extra cycles, because it's 5 cycles to do this versus 4 cycles to do this. I figured this is also incurring that penalty because you have to get the tile data, and this is probably the only practical way to do it, really, because of the variability. Maybe I come up with a better way, but to get it working, I wanted to just try the obvious method for this because it's easiest to put together. So we go down and we do all this stuff for the tile. Like I said, and then we do another routine again, because all of these are hard coded. And there's probably there may or may not be better ways to do this. I haven't really looked at optimizing this yet in terms of memory space, but in terms of performance, I already know this is going to be the fastest way to do it. Well, maybe not the fastest, maybe not absolute, but it's going to be one of the fastest methods. It's very, very quick, relatively. Because again, just on the storing alone, you save 3,800 cycles. So you're saving 4,000 cycles, and on a machine that runs at 100,000 cycles per second, I mean that's 4% faster right there, just for that one thing. Let alone the other optimizations that are going on in here. We basically, well, I don't want to get in the code of this too much. We're not really looking to break down the code in this. This is just an introductory video of the idea of what we're doing and what we're trying to accomplish. So we basically replicate this all the way down. Now, the practical upshot of that is, with the tables, because I got various buffers. This is a map buffer. This is my tile address table. There's going to be some stuff down here. Eventually, this will be the map, like what would simulate the map buffer from the disk. This will be 1 kilobyte down here. Eventually, I got to construct it yet. And this will be the area around Lord British's castle, just so we have a familiar area to look at. And I got some jump tables, and then the animation routines for the water. Again, these are not optimized. I just made one routine for each tile, again, just to be explicit. Again, I might be able to combine this down a little bit for memory. It's not a lot of memory, though. It's only 50 or 60 bytes or something. The result of that is that this entire routine so far is 4K of memory. again, very ridiculously extravagant on a what amounts to a 48K machine. It is possible to use it this way, though. I mean, again, you've got 8K memory for your graphics screen, and you've got then 4K for this. That's 12K and 8K for your tiles. So you got 20K use up. So you still have 28K without using the memory under the ROM. So you could make a game with this, really, straight out, you know. I'm sure there's ways to optimize this a bit, but we'd have to figure out those design considerations of speed. Because the goal here, remember, is not to... I'm not really trying to design a game engine. I'm not really trying to design, you know, something that is that practical. I'm trying to work up what is the best performance possible on an Apple II drawing a tile set like this. That was the thing, is could we improve upon what was done in the commercial release with not as many considerations as they would have, obviously. Again, you have to kind of weigh that when you're doing an actual game, because it has to work and fit in the memory and have all the other features it has. So definitely making a game this way. But I was looking at this from just a proof of concept, as a graphic, you know, not really a demo scene type thing, but just saying, hey, what if we took that and made it as fast as possible? What would that involve? What would be the ways to do that? And again, I haven't really optimized the code or gone through other possibilities here. I came up with this method and said, let's try it. I did some tests, and it was very fast. And I said, okay. And just to give you an idea of the speed here, well, you can't really tell, but if we run this, when I run this, it invokes the machine language routine, and it waits for a key press before it draws the screen, because I didn't want it to just immediately draw the screen after it clears the graphic screen, so that you couldn't tell how quickly it's drawing. And you can't really tell because it's going to be basically instantaneous. So if I hit a key now, it will draw the screen. And you can see that's pretty much instant, or at least it's so fast that you can't really tell. If we slow this down to half speed, let me quit out here. Okay. You can see even at half speed, that's still pretty quick. My estimate is if I ran it at half speed, it would be almost the same speed as the actual game itself, the actual Ultima games. But again, those are estimates. I got to do some animation tests and get some videos and do some timing tests and get my animations. I got the animation code. I just have to test it out and do a couple things with it and all that. So anyway, this is just an introductory video for the kind of ideas, what we want to do here, and what I'm trying to accomplish. Partially also, it was because I couldn't find any information on the Ultima stuff in terms of the tile sets. I had to make my own. Someone had come up with, and I do talk about this in the next video where we break down that process, but someone had put together graphics screens, like captures of the tiles, but those are in screen memory. They're not obviously laid out in tile format that you need. So I had to write a conversion program for that. The next video will go into that, because I couldn't really find anyone that had the original Apple tile sets in like data files. So I had to make my own. And Ultima 5, by the way, has 512 tiles. So that one will be split into two different sets, because really the first 256 are the only ones that get displayed. The other 256 set is really for animations and masking stuff and things that it uses for animations. So that would reside somewhere else in memory. Presumably they put that underneath the ROM and just grabbed what they needed for, you know, temporary animations, or pull in just only the animation tiles they needed for any given time, or something like that. Anyway, that's the goal here. See if anybody's interested in this. My ultimate goal here, well, ultimate, but is to get this running as a very simple. You can move around a little bit, and it does the animations, some of the animations. I'm not going to animate every single thing, but I probably will animate things like these flags. Like as an example, these flags, you could just really all these flags do is reverse position. So you just have to take this byte and flip them. So it's very quick to do. You could actually make these animate so fast they would look ridiculous. So we'll have to put in like a delay, like a random delay, so they flip periodically and not every single frame. But certain other things, you know, like a fountain, flames, and stuff like that, you'd want to have, which may not exist in Ultima 4, they're more of an Ultima 5 thing, would be something. But you could use this as a basis to build that sort of a system on if anybody wanted to. And I may try to tackle a tile editor, which I don't think exists for the Apple II for something like this. So I may tackle that. We'll see. That's a little trickier, obviously, because there's a lot of bit flipping and stuff to do, and I'm really not going to write that in machine language, so it's going to have to be a hybrid between AppleSoft and machine language just to make it easier to get around. So I'll see about maybe doing that if I can, if I get adventurous about it. But anyway, so proof of concept, like I said, trying to find the fastest way possible to draw and animate the screen, and we'll see how this goes. Thank you.